Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and a spherical Gaussian surface encloses a positive charge Q. Explain with reason what happens to the net electric flux through the Gaussian surface in the following cases. So we are having a spherical Gaussian surface like this. Let the radius of this spherical surface is small r. And we are having a charge small q that is enclosed inside this Gaussian surface. We need to find the electric flux that is passing through this Gaussian surface. So we know that the electric flux phi E, it is given by Gauss's law as Q divided by epsilon naught, where Q is the charge enclosed by the Gaussian surface. Now, if the charge is tripled, so earlier phi E was Q upon epsilon naught, now Q has become 3 times Q. So phi E dash, it will be 3Q upon epsilon naught, because the charge enclosed will now be 3 times Q. And we can see from this phi E dash is equal to 3 times phi E. This value that I'm encircling, it is phi E. So when charge enclosed is tripled, then the net flux through the Gaussian surface will also become 3 times. 3 times. As phi E is directly proportional to Q. So that's the answer for part A. Now let's take part B. If the volume of the sphere is tripled, so we are just changing the volume of the sphere. We are not changing anything else. So it means we are changing the radius. So now if earlier the radius was r, now we have changed it in such a way that its volume has become 3 times. But that does not change the charge enclosed. Charge enclosed will remain same. And the permittivity, it will also remain same. Volume has no role to play in the electric flux. So for part B, there will be no change in the flux. Let's take part C. If the shape of this Gaussian surface is changed into a cuboid. So if we are changing the Gaussian surface to a cuboid and the charge inside it remains the same, then also phi E is equal to Q upon epsilon naught. Because changing the shape will not affect the electric flux as long as the charge is remaining inside the shape that we are taking. Let's take part C. So for part C, we have written that no change. And for part D, if the charge is moved into another location inside the Gaussian surface. So we are having the Gaussian surface. Earlier, if the charge was here, now I have taken this charge from here to this place. Again, there will be no change as long as the charge remains inside the surface. If it comes out of the surface, then flux will become 0. So we have to take all the charges that are inside only, and we do not be bothering about the charges that are present outside. So for part D, there will be no change. And that's the answer for this question. Keep learning, keep practicing, keep excelling.